So today we'll continue from the previous session. As in the previous session we talked about evolution of operating system, that how operating system has evolved as the time rolls on and how the new functionalities has been added into the operating system. We talked about sequential processing system, and we saw that in sequential processing system a lot of manual intervention is there, and it takes a lot of setup time, and in order to operate with computer we need skilled persons for it, and there are many drawbacks. That's why we generally move to batch processing systems. In batch processing system we submit to computer a set of jobs, then a slight refinement of a new operating system. Like for the first operating system which was used in batch processing system called resident monitor was introduced, and the job of this resident monitor is be in between set of jobs, okay, how to move control between one set of jobs to another set of jobs, okay, is the job of your resident monitor. And this information can be given to this resident monitor with the help of job control language. And we saw multi-programming then. So actually today we have to talk from multi-programming, right? We saw that in batch processing system we have few drawbacks. Okay, first drawbacks is all the jobs will be executed in sequential manner. And the types of all jobs are of same type. Okay. Now I have job 1, job 2, and job 3, job 4. I don't have any mechanism to take any job randomly, and because all of them are processed sequentially, assume that while this job 1 is executed, job 4 is in urgency, it's in urgent, right? Then it doesn't get control unless and until all these jobs are completed. If in a queue, if I start numbering from 1, 2, 3, 4, if nth job is in urgency, it is possible to gain the focus of CPU only after n-1 jobs have already been completed. Okay, that is a problem. And because of this, all these jobs suffers from high response time. They have high response time. And while a process is executing, or we use the term job here, job is executing, then no other users are not allowed to interact with this job. Okay, while a job is executing, we cannot interact, or a user cannot interact with it. Can't interact with it. Okay. Now all these are the problems in batch processing. Now multi-programming has overcome all this by a simple concept called dividing the memory into multiple partitions and accommodating in each and every partition one job. Okay. So multi-programming is the ability of an operating system to accommodate more than one jobs in a memory, and now because of this you can have different types of jobs in memory: job 1, job 5, job 6, 7, job 1, and job 5. 5A, this 5B. Different kinds of jobs are possible, and it's not necessarily that all these jobs have to be processed in a sequential manner. They can be accessed in the order which depends on scheduling algorithm, right? So sequential manner has been eliminated, and you can have different types of jobs. Okay, and generally the advantage of multi-programming is good response time. It's not a good response time. Still, it suffers from high response time. Why? Because suppose when job J1 is executing, and it is now let's classify here jobs are of two different types. Okay, you have one job which takes a lot of CPU time. Okay, and I call it as JCPU. It means it is CPU intensive job. And I have another job which is IO intensive. It means CPU intensive jobs are those jobs which takes lot of processing times. In order to complete themselves, they need lot of CPU time. Okay. And IO job, they need very less CPU time, and much of the time will be spent on doing IO. So if this CPU intense job is executed, then all the small jobs which are here, okay, that doesn't get attention very immediately. So it still suffers from response time. It has not been eliminated, right? So while a job is executing, user can't interact with it. Okay, but whereas in multi-programming, okay, it is it possible really to interact with the job while this job is running? Okay. So in multi-programming, this problem also persists, right? Because preemption is not allowed here. Here the CPU leaves. The process leaves the CPU only under two situations. Once, if the process has completed its execution, or the process has performing some IO operation. So in these two situations, only a process or a job leaves this CPU. So in order to overcome these two drawbacks, that how to reduce this high response time, and how to make it possible that job interacts with the user, okay, while it is executing. How a user can interact with the job while it is executing. Still small level of interaction is possible in multi-programming, but because of non-preemption, okay, it's not that much interactive. So because of that, we have another evolution in operating system called time sharing systems. Okay. So what is time sharing system? Time sharing systems are nothing but they have all the features or capabilities of multi-programming. Apart from that, it has a few extra features. Okay. Let me discuss what are those. So as I have told you, all the features of multi-programming you have in time sharing system. Time sharing system. I have job 1, job 2, job 3, job 4, right? So all of these jobs are there, and they can be scheduled randomly according to the scheduling algorithm. But once job has been selected, it leaves the CPU only under two situations. Here in multi-programming, it leaves this job will leave the CPU only in two situations. Okay, one is if it has performing some IO operation, or job has been terminated. But in time sharing system, this job, when it has been given to any CPU, then this job will leave the CPU in three situations. Okay? Two situations which we have got from the multi-programming, and one is when process time slice is completed. Time slice elapsed. So here we have a new concept of time slicing here. In time sharing system, each and every job, okay, is given certain amount of time. Okay, we call it as time quantum or time slice. Time slice. Now, what is the purpose of this time quantum and time slice? The purpose of time quantum and time slice is this: when any process is in urgency, right? Then if a process which is IO intensive, if it is executing, then it eats up most of the time of CPU, thereby doing unfair to a process which is in urgency. So in order to accommodate those situations and allow average response time, a good response time on an average for all the processes, the concept of response time has been introduced. Here, each and every job will be paid attention to this duration of time. So how do you define this time quantum? So if the operating system has time quantum for every process, it means that no process can take the CPU time more than this time. Okay? So this is the maximum. Time quantum is the maximum amount of time that can be enjoyed by any process. Okay? No process can take more than this time quantum duration of time. So that's what the time sharing system is. Here, each and every job will be paid some attention till this time slice, time quantum elapsed. Okay? Once this time quantum elapsed, then forcefully that process has to be taken away from that CPU, and another job from this memory will be selected according to the scheduling decision, and it will be given to CPU. So that is the main difference between time sharing and multi-programming. Now, because of this time slice or time sharing, the response time increased, and it's a very good it's really a very good thing that we have decreased the average we have decreased the response time. So how do you define response time? Response time is, now when a user has given an input, okay, after giving the input and before he receives the output, he sees the output, the time interval between the user has given an input and he has received the output, that time interval we call it as a response time. So this response time, generally users want this response time to be very less. Okay? Nobody want to waste a lot of time in just waiting for output to come. Nowadays, online has become computation has become online activity, and all of them or all of us want output to come very fastly. So that's what it's very important to have this time slice or time quantum. Nowadays, all operating systems have this time slicing and time quantum concept inbuilt in them. So so because of this, we have increased in we have reduced the response time. Response time has been reduced, and it is possible for the user to interact with the process while it is executing. Okay, so interaction while executing is possible, but whereas in batch processing system it was not possible. Right? So in time sharing system it is possible. So how do you define a time sharing in simple term? Time sharing is nothing but multi-programming plus preemption. Okay? If you allow preemption, what do you mean by preemption? Preemption is nothing but when any job is executing on CPU. Okay? Now, if forcefully, because the time quantum which is given for this job is elapsed, okay, so that because of the time elapsing of time quantum, the job will be taken from the CPU and again it will be kept in the ready queue. Okay. Because of this situation called preemption, taking forcefully CPU from process, is called preemption. Okay, so preemption involves context switching, which we will see what it is actually. So this is about time sharing system. Now after this time sharing system, and the evolution of operating system was, so far the operating system was dealing with only one processor. Now people want many number of processors to be present in a single computer, thereby increasing their computational power. So those kind of systems in which more than one processor are there called multiprocessor system or multiprocessing system. So multiprocessor and multiprocessing both are the same terms. So multiprocessing. Now multiprocessing is possible only if you have multiple CPUs. Okay? If more than 2 CPUs or 2 or more than 2 CPUs are present in a system, then it is called multiprocessor system. And execution of multiple processes simultaneously on different processors is called multiprocessing. Now, this earlier in time sharing system, we were having only one CPU, one processor, and n number of processes. And all these processes are getting executed on single CPU,